So let us keep on going with lesson 15. We are going to be working through session 3 today, starting on page 325. We are going to multiply to find area. So again, always remembering what area is. It is the space inside a flat two-dimensional closed figure. It is measured in square units. If the unit of measurement is identified, we are using that unit of measurement in our solution or answer. You know, I don't always like that word, but our solution to the problem. So again, when we are calculating area using the formula area equals length times the width, that solution will always be expressed in square units. You're not just solving for a multiplication fact. Please be very, very careful with that. All right, we did talk a lot about our modeling. We talked a lot about how we could use tiling, for example, and how those tiles have to stay inside the boundary of that two-dimensional closed figure, and those tiles cannot overlap and be a big hot mess inside the figure. They have to be nice and neat and wonderful. And then we all looked at that and saw, oh, that's an array. That's an array like we build in multiplication. And from there, we can figure out how many groups, how many are in each group, and then we can look at it as a multiplication problem with that type of operation. We're going to keep on doing this, friends. We're going to keep on modeling, keep on modeling, keep on modeling. I saw yesterday that there were a few of you who were still expressing your solutions to your problems with just a number. You got the right number, you did the right math, but you weren't answering the question. Remember, we talked about that too. Please always answer the question that is being asked of you. If I want you to solve multiplication facts, I'm going to be clear about that. If I want you to give me the solution for area, I'm going to be very clear about that. And it has to be expressed in square units. If I want you to only give me the measurement of one of the sides of a closed two-dimensional shape, I'm going to be clear about that. And that's going to be expressed in the unit of measurement. But that isn't square units because it's just a side. Break down those questions. Remember to understand what you're being asked before you proceed. If you don't know what's being asked of you, stop. Slow down, back up, get those markers out, start close reading. Make sure you understand before you proceed. If there is more than one part to the problem, my students know I like to number those parts. Oh, here's a question, that's part 1, and oh, here's a question, and that's part 2, so that I know I'm answering all of them. Why is this important? Because today, as many of you are seeing on page 325, now we're going to start some word problems. Solving word problems using this concept of area and multiplying to find it. And you will see very quickly that the very first question that we have is 2 parts. Please use caution, my friends. Please use caution. Now, in a moment, I'm going to share my screen. We're going to talk about page 325 and that problem that is before you. Give me just one moment so I can get my screen up for you. All right, everyone. So again, up at page 325, up at the top, we're going to talk about Tyler and Suki. Here we go. Tyler's rectangular bedroom floor is 9 feet wide and 9 feet long. So we can see very clearly here that that is a square. 9 feet wide, 9 feet long. That's a square. The sides are the same. Suki's rectangular bedroom floor is 8 feet wide and 10 feet long. Whose bedroom floor has a greater area? Now, you can see that we have Tyler and his floor is 9 feet wide. We have Suki, her floor is 8 feet wide, 10 feet long. And I'm sorry, I forgot to put Tyler's length. He's 9 feet long. So you're being asked, who has the greater area? What is the greater area? So in order to solve this problem, friends, you first have to find the area of Tyler's bedroom floor. Then you have to find the area of Suki's bedroom floor. And then you have to find the difference between the two. The word difference is the clue that this is going to be a subtraction problem in the end. All right, so again, we are finding the area of Tyler's bedroom floor. Then we are finding the area of Suki's bedroom floor. Then we are finding the difference between the two. All right, can we model this? Yes, we can. Can we use tiles? Yes, we can. Do we have to do all of the tiling and build an array? No, we do not. Because now that we know through our formula of area equals length times the width, we simply have to model out the length, model out the width, and do the multiplication. All right, so in taking a look at Tyler's floor, we can see, and I'm going to move this out so you have just a flat board. So we are seeing that Tyler has a rectangular floor 9 feet by 9 feet. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right. And then we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So, and yes, sometimes the tiles kind of slide around, and that's okay, but we will pretend that they're all perfect. So this partial model is representing Tyler's bedroom floor. We can see that it is 9, we're going to call these feet, 9 feet wide, 9 feet long. So can we solve only using this model? We definitely can, because we know that area equals length times the width. This we know. We know that the length is 9. We know that the width is 9. All things we know, my friends. And so this multiplication fact has a product of 81. We are not done because we need the area, which is always expressed in square units. So the area of Tyler's bedroom floor is going to be 81. Unit of measurement is feet, FT period, square units. So again, we have it 9 feet wide, 9 feet long. Area equals length times the width. It is 9 by 9, which is going to give us a solution of 81 square feet. Okay, so we're going to call that, all this work, we're going to call that that was step 1 of our problem, right? Step 1. So we're all done there. Awesome. But now we need to move on to Suki. Now we need to move on to Suki. So I'm going to move this board for just a moment. And I'm going to be using another board now. This is going to represent Suki. So Suki is 10 feet long. Here we go. 2, 4, 6, 8, and 10. And Suki is 8 feet wide. 1, 2, 3, 4, 5, 6, 7, and 8. And there is our partial model. Again, it is 10 feet by 8 feet. Do we have all that we need to solve for area? We absolutely do. Again, friends, it is area equals length times the width. We do know that for Suki, it is 10 feet long by 8 feet wide. We know that the product for this multiplication fact is 80, but we are not done because I am asking you for the area of this bedroom floor. So the area is going to be 80. Unit of measurement is feet, and it's always expressed in square units. So Suki's bedroom floor is 80 square feet in area. So again, this is step number 2. So all that is left for us to do is to figure out who has more space. Who has more space? So if we take another look at Tyler, Tyler's 81. We look at Suki, Suki is 80. We can clearly see that Tyler has a slightly larger bedroom floor because 81 is larger than 80. All right? Area equals length times width, my friends. I'll give you a minute to write out whatever more notes you would like to have there. All right, friends, so at the top of page 326, you can see here that it is repeating the problem that we just worked through, but it's giving you a different way to picture it and model it. So again, in review, we're seeing Tyler's bedroom floor is a 9 by 9. Suki's bedroom floor is a 10 by 8. In the first instance, we modeled it using tiles and we created a partial model. But could we also simply just take the formula and plug the formula in to solve the problem? Yes, we could. You can see down here at the bottom where it says model it, that's exactly what they did. And you will notice that they even color-coded it for you. You will see down here on the model it where it says that you can also use multiplication equations to find it. The length is in red, the width is in blue. And they're giving you Tyler's floor, 9 by 9, which of course is 81. We determined that is 81 square feet. We can see Suki's floor, 80, and we determine that square feet. And if we do the simple subtraction, friends, It is simply 81 minus 80. Tyler's floor is greater by 1 square foot. Again, friends, it is 3 steps. We are finding Tyler's area. We are finding Suki's area. We are subtracting to find the difference, to answer the question, who has more space or area? All right?